Hello friends, myself Professor Joytande. Today we discuss experiment number 2 of industrial instrumentation to study the measurements of linear variable displacement using linear variable differential transformer, that is called Lvdt. So we saw some figure of Lvdt, which is internal part. You can see the 3 winding, right? Copper winding. So one that is a primary and 2 that is a secondary, which is indicated by A and B respectively. Now introductions of Lvdt. Basically Lvdt used for displacement measurement. Its some other types are resistive potentiometer, Lvdt, strain gauge, capacitive transducer, variable inductance transducer, piezoelectric transducer, photoelectric transducer, polyphase transducer and digital transducer. Among and today we discuss about this Lvdt. Now Lvdt is an electromechanical transducer that helps to convert the linear motions of objects into the electrical signal. That's why it is called as a transducer. The transducer actual definition is the device which can convert the variations in the physical quantity such as a pressure or brightness into the electrical signal or vice versa. So the Lvdt that's convert the rectangular movements of objects into its equivalent electrical signal. Hence the Lvdt is used to calculate the displacement. Lvdt is work on a basic principle of transformer mutual inductance. So I say it's a AC control. Now so electrical component inside it, they work at a very low temperature. When it converts the mechanical motion into electrical signal, it gives the phase and amplitude information about the devices. Now the entire operations of Lvdt work on electromagnetic coupling. So as I told you, that mutual inductance concept. Now definition, the term of Lvdt stands to be linear variable differential transformer. It's mostly widely used in inductive transducer that converts linear motion into electrical signal. Output across the secondary of the transformer is differential process also because of the variations in the displacement. So output of the transformer of the Lvdt that will be changed because the core is changed. So this is very accurate inductive transducer as compared to the other inductive transducer. Now you can see some construction with cross-section views. I already mentioned the having the 3 winding, right? One that is a primary, second that is a secondary. So these 2 are the primary. This is the hollow part, this is the core which is to be displaced. Now see, here is a little bit some secondary connection. You can see this. So the voltage across these and these, we can say the voltage across these, that is V1 and here is the V2. So total voltage of the secondary, that is the difference between the output voltage of the secondary. When the core is displaced, means it is maybe forward to it's up down, right, left to right side. It's movable core. So whatever the linking between primary and secondary, that will be changed. So here we can understand electrically, primary we give the AC supply, secondary it's having a C. You can see the terminal that will be series connected with that. So first coil having a one terminal and second coil having the first terminal. That make the VC. Now the principle of operation. Here is some animated video. You can see there are 3 conditions over here. When the core is here, the conditions that is like this: E output is equal to E1 minus E2. E1 that is the primary, secondary, one secondary S1 voltage and E2 that is another secondary voltage. Right. So you can see when the core is here, the pointer is like here, left hand side. It may be E2, E1 minus E2. So difference between that. When the core is at center side, the condition is like that. Means that is a half of voltage that will be generated on secondary side. So actually positive half and half negative half. So ultimately the resultant is 0 volt. So when the pointer is middle side, you can see the pointer is, when the core is at this side center position, the pointer is here, that is a 0 value. So here is a negative value, here is a positive value. So you can say 0, positive and negative. Now the third condition, that is when the pointer is over here, you can see the pointer is right hand side. So at that time the voltage E2 minus E2. Here is the primary input, secondary That is a secondary. These are some connection, and for checking the voltage we have connect some voltage. Now LVDT advantages and disadvantages. LVDT has a very high output. It does not need any extension. LVDT shows very less and small hysteresis. Power consumption by the LVDT is very low, up to 1 volt only. It does not have any frictional losses. That is most important. Now some limitation can be used up to the range only 1.25 mm to 250 mm. Now the temperature is varying and the vibration affect LVDT. Now practical application. LVDT is to measure the weight, force, pressure and displacement. LVDT can act the primary and secondary transducer. For example, in the pressure measurement, when the burden tubes act as a primary transducer, it helps to convert this displacement of the burden tube, which is connected with the shaft of the LVDT, can measure. So it can be measured on not only for the displacement, it can also measure for the pressure as well as force. Now there are some industrial automations such as aircraft, satellites, hydraulic, and that's it.